folks, welcome back. Today is going to be the review from, you guys probably can't hear me very well. I should move my microphone where I can talk into it. Well, we're going to be reviewing the submitted waveforms for week 13. If I'm too quiet, let me know. I don't want to blow your eardrums out, but I don't want you to have to hold your phone up to your ear if you're watching on a mobile device. Welcome everybody. I see a lot of familiar faces in the crowd already. Okay. So this week we did captures on fuel pump current ramping. We had a couple of good submissions in here. I know that the video, it seems to never fail. I never have a vehicle that is the perfect test vehicle sitting in the bay, but made do and got something captured at least. It's always best to capture known good waveforms on vehicles that you don't think have a problem. And you'll see a wide variety of fuel pump current waveforms, even on known good vehicles, even on new vehicles or vehicles that have new pumps. So it's good to see quite a range of those, and then also to test it on vehicles that you think have a problem and see if you see a difference there. And then at some point here, I'll probably have to search for it again. But I want to link with you guys the Delphi website. They have a chart for all the fuel pump applications out there and what the recommended amperage is, or what the specification for the amperage of that fuel pump is. Because let's face it, we all work on most of us work on a wide variety of vehicles, and the amperage may be shockingly high on some and very low on others. So let's just jump right into it. And I'll refresh this once we get to the bottom. The last one I saw in here was from Bob Newman. He had this is one he captured previously. So I don't know if you guys could hear that. My dog's sighing in the background. She's been doing that all day. She's tired of listening to me talk. One he diagnosed 3 years ago, when he had his Modus Ultra 2000 Mercedes-Benz ML320, 3.2 liter with 200,000 miles on the clock. It'll only idle, has no power when accelerating, check engine lights on. He only had 20 psi of fuel pressure, and it would gradually fall as he brought the RPM up. And I want to talk about that a little bit. I'll probably do a video on pressure checking, but we'll talk about it a little bit as we go through this one as well. He checked power and ground of the pump, and it all checked out good. And then he has a amp clamp on there as well. So we'll open up his picture. So instead of seeing a nice even waveform here where we can see the commutator bars, he has a section where it just drops out completely and then jumps back up, and then drops out completely and jumps back up. And this is a pretty obvious fault with that fuel pump. I wish they were all that obvious. I like the ones that show 0 amps and you tap on the tank a little bit and then you'll get little spikes, or it'll start turning a couple times and then stop. So this is what I like to see when you're checking for a bad fuel pump, because it makes calling that fuel pump pretty easy to do. But when it does run, that pump is pulling 12.5 amps. I'm not sure what the spec is on this one, but Bob has a known good capture after replacing the pump, so we can see what a known good looks like. So here's his known good. Oh, I didn't say the pump RPM. He said the pump is rotating at approximately 1300 RPM. Now the new pump is 6500 RPM. Now I typically see 5000 to 6500, or maybe even 7000 depending on the vehicle. And depending on if it's a computer controlled or has a fuel pump control module that can slow that pump down. It looks like it's pulling less than 5 amps. We can see nice even waveform here from the fuel pump commutator bars. So I normally don't see a waveform this clean after putting a new pump in. So this is probably a decent pump. Sometimes your waveform will look a little bit rough when you put a new pump in, because it has to go through a break-in cycle. They don't always work 100% out of the box, or they're not broken in 100%. So this one looks pretty good. And he saved his capture, or took a picture of it at least, so he has a known good reference waveform in case one of these vehicles ever comes in again. Now the vehicle is up on the top of the screen, so I'm guessing that Bob went through the guided component test meter in the snap-on scope. That way it would save the information here when he saves the capture. If you go straight into the lab scope like I normally do, and you're using the Modus or the Triton, then it's not going to save that vehicle information. Hey Clay, how's it going? Glad you could join us and learn a few automotive things. William Cantrell has one here. He has his notes here, and someone was asking where the number 60,000 came from. So I'll cover that as well because I didn't cover that in the video. So he has a 2005 Dodge Dakota fuel pump current, and this one was pulling between 6 and 8 amps. And he has two measurements here. Now, I said if you're using the snap-on scanner, you can just look at the frequency down here, which this one says 90.87 hertz. And William went ahead and did the math for us. If we have 90 cycles per second, and we want to find out how many cycles per minute, well, we have 60 seconds in a minute. So we're going to do 90.87 times 60, which comes out to 5,452 RPM. If you're using a scope that doesn't have the frequency calculated for you, like the U scope, I believe that it does milliseconds. It might do frequency as well. But if you're only using a scope that has milliseconds and you measure from 2 spots and you have, this one was 11 milliseconds, well, how many milliseconds do we have in a second? We have 1,000 of them. And there's 60 seconds in a minute. So 1,000 times 60 equals 60,000. And then he divided that by what his measurement was. So 60,000 divided by 11 milliseconds. And he came up with 5454. So between those two different calculations, we were only off by 2 RPM from this calculation to that calculation. So with that margin of error, because this measurement here isn't going into multiple decimal points, that's pretty good. So you can do it either way. Thank you for that one. And I believe that, yeah, you responded to that one as well. Jira has one. 2013 Toyota Tundra, performed TSB 0166-19. So this is a Toyota service bulletin. Came in for extended crank and cold start. He grabbed a capture. And I'm guessing the service bulletin is about replacing the fuel pump for an extended crank situation. I don't know if it's bleeding pressure back or maybe that pump's taking a second to spin up. I didn't actually read the bulletin there, but he has between 8 and 9 amps. The waveform's fairly even. I don't see any anomalies here that would say, hey, this is a bad pump, the brushes are bad. Toyota makes pretty good pumps for the most part. Most of my vehicles have the original fuel pump in it, and I have 3 Toyotas with over 300,000 miles on them. So they don't fail very often. This one probably has a bad check valve and is bleeding back. And this one has a fuse for the fuel pump, so easy to throw a AES wave test lead in there, put your amp clamp around it to get that measurement or that waveform. Most Toyotas don't have a dedicated fuel pump fuse. They might have a fuel injection fuse or a EFI fuse, but sometimes there's other things that can power off of that fuse as well. I wish they all had the fuel pump fuse, and I wish that all Toyotas would do a clear flood mode. Robert has a 2018 Toyota Highlander. Now, I've been waiting for something like this to come in the door, and it hasn't happened yet. So, because I wanted this to be next week's waveform. But now that I think about it, I don't know if I will do a 3-phase pump as a weekly waveform, just because it'll be very difficult for most people to find a test vehicle to do it on. So I'll probably just do it as a supplemental video to go along with this week's video. I'll just make it like 13.5 or something for the waveform video. And then if people post up about it, we'll cover it. Oh, and Jiro said that was the new pump, not the old pump. So new pump, we see slight variations in there, and that may smooth out over time. And Jira, is that the issue with those? The check valve is causing a fuel bleed back issue, and I don't remember if those are returnless fuel or not. We don't see too many issues with them, so it's not something that's ingrained into my brain. And Robert posted a 2018 Toyota Highlander 3-phase fuel pump, known good. So I need to do a complete video on the 3-phase brushless DC motors, because they operate like a 3-phase AC system. Like old industrial shops had 3-phase power, big high horsepower motors were 3-phase. Instead of like our regular wall outlet where we have 120 volts AC here in America, and it cycles up and down in a sine wave 60 times per second. And then we have just a neutral leg. And then you get 220, which is 2 legs of that. And they're alternating. I believe they're opposite of each other, or maybe they're, I can't remember. But 3-phase, you have 3 different legs. So you normally have like a 3-pin plug or a 4-pin plug, so you can still have your redundant ground. And the waves are all staggered from each other. And it creates a very, very powerful power supply that uses, I think, lower amperage than normal. But they can do some pretty fancy stuff with it, and that's one of the easiest ways, I believe, to control a DC brushless motor as well, is to do it with AC. Otherwise, they have to have brushes in there, and they have to have the magnet on the outside and the windings on the inside. But when we measure these, we have to measure all 3 legs and see what the voltage does. So we're either going to have it pulled to ground by the computer, it's going to be a floating voltage, or it's going to be lifted to power. So it takes a little bit of effort to analyze it. And I think this is current down here at the bottom. But anything below the midpoint is probably a negative current. So we're sitting down here, we might have a negative current, and then it goes back up to 0, and then goes up and rises again to positive current. So it looks kind of like AC, but it's DC. It's all happening above the 0 volt mark, but our current is going back and forth. I'll have to do a separate video completely on the DC brushless fuel pumps. And he was testing this one at the fuel pump. Luckily, this vehicle had an access panel. He's back probed into the connector, and then he has his amp clamp. I don't see it in this picture, but the amp clamp is around just one leg of that. And here we have a fuel pump control module down here at the bottom. And then we have pump winding U, W, and V. And I believe they use some of the same terminology for like the hybrid stuff, because those are all 3-phase AC motors as well. And I know Toyota has a recall on the fuel pumps, and I think that applies to both the regular conventional brush style fuel pump and some of the DC brushless fuel pumps. Doug Wilson has a 93 GMC 5.7. Okay, I was making sure it looked like a fuel pump deal, but he was talking about the charging system, so I was making sure it wasn't our alternator ripple. So he said not charging, the first battery voltage was around 11 volts. Second, after the alternator replacement, and it was charging voltage. It's a TBI vehicle, which is a throttle body injection. So this system runs, I think the spec is normally like 9 to 14 pounds or 9 to 13 pounds. So it's a lot lower than what we're used to seeing on the modern vehicles, which means the pump may not have to work quite as much or quite as hard. So when he was at 11 volts, we were only pulling about 3 amps of power, and his RPM, he didn't calculate it, 72 hertz. So I'll do 72 times 60. Not in my head. It is only 4,300 RPM. And then here we're pulling about 4 amps once we have full operating voltage. The alternator's charging. He mentioned that we're probably around 14 volts. And now we're at 92 hertz. which is 5,500 RPM. Okay, on the Flex Fuel Tundra, they have you recalibrate the ECM and perform an alcohol density reset. Heard a rumor that something with the ECM control of the fuel pump causes excessive wear. So that one must be a variable fuel pump as well. And I wonder if it senses a high density of alcohol, if it runs the pump harder or higher and raises the fuel pressure up. Like I said, we don't see many issues. I was surprised the other day when I had a 4Runner with the, I think I showed a capture of it. I'm not sure. But I had a 4Runner with a bad fuel pump. It was the pump was locked up. I think I showed, actually, so that would make 3 pumps that I had that were locked up. I had a Ford that I showed in the video, and a Nissan I showed in the video, and then that Toyota 4Runner. Doug also posted a 95 Ford F-150 with a 5.0. No issues, just easy to gather. So this one's pulling about 4.5 amps. And the RPM is 104 on this one. So we're kind of all over the place on our pump speed. So there's not a definitive, yeah, if it's below 5,000 RPM, it's bad. Or above this, it's bad. This one was pulling or running at 6,200 RPM. And this one had a fuel pump fuse. He has his AES wave fuel pump loop in there. Thank you, Doug. Okay, Nick Chen has one here. Week 13 fuel pumps current. Vehicle is a Vespa GTS 125 start stop. Now, I'm assuming this isn't in America. I don't know if this Vespa is a car or if it's a scooter. But I don't know if I would want a Vespa scooter that has a start-stop system. But then again, like the old golf carts that were gas-powered, they were all start-stop, and they were like 2 strokes. And if you guys are... I'm going to go off on a tangent real quick on electric golf carts. Because I worked at an amusement park in high school, and we had gas-powered golf carts, and I learned a little bit about them. So those have a switch, a lever that you kick from forward to reverse. Every time you let off the accelerator, the engine stalls. What they do, since it's a 2-stroke motor, that motor can run in reverse and run the same way as if it's going forward. There's no camshaft. So if you have the lever to forward, you hit the gas, the starter spins up the engine in a forward direction, and you go. If you come to a stop, you flip it over to reverse, you hit the gas pedal again, it runs the starter backwards, it switches the polarity, and it spins up that engine in a reverse direction. And everything else remains the same because it has reed valves and everything to control the air going in and going out. And it just runs the engine backwards to back you up. So kind of a weird fact I learned when I worked at an amusement park. So back to this Vespa GTS 125 start-stop system. It would intermittently not start after stopping at a traffic light. And we can see why in this capture. So we see a waveform and then we see a dropout. This is a open in the fuel pump winding or a bad commutator bar. So there's one spot of this fuel pump where electricity is not passing through the pump very easily. If we come to a stop sign and this Vespa shuts off and that pump lands on that one spot, the pump's not gonna start back up. If it's a car and you hit the gas pedal, or if it's a scooter and you twist the accelerator, it's not going to spin that pump back up. I don't think that I would want to be in that situation in a car or a scooter where it automatically shut off on me when I told it not to, and then it won't start back up. That would be a bad day. Normally, if you have a pump like this, if you see a capture like this, or if you have a vehicle in the parking lot that won't start, you can bang on the gas tank. Once the pump is up and running, it'll normally stay running because it has enough speed to carry it past that burnt part of the commutator bar, and get to a good spot. Bart says that some ship engines fire up backwards for reverse. Well, that's interesting as well. And I wonder how that works, because they even have two-stroke diesel engines. Wasn't one of the Detroits a two-stroke diesel? And a lot of ship engines are two diesels. But you see, like on the Titanic, they have that gigantic prop shaft going out the back of the boat. I wonder if that's directly connected to the output of that engine, and to put it in reverse, if they have to kill that engine and actually get it spinning in the other direction. I'll have to look into that one. Thanks, Bart. More information for my brain to absorb. Oh, the other thing I just noticed is this pump is pulling very, very low amperage. Even the bad pump was only pulling 2.5 amps. And he has a capture overlaid here with a new pump. And it's only pulling 1.5 amps. So that must be a very, very small fuel pump. I'm guessing this is a scooter. I just tried closing the Picoscope screen on here. Let's see. Angel has one. 2016 Ford F-250 with a 6.2 liter engine. So he's submitting week 12 and 13 captures all at once. He said there's a lot of noise in the injector waveform. He was using the Handtech breakout leads. Used them before but didn't have this problem. Lastly, the fuel pump waveform, a bit choppy but no drivability complaints. So week 12 was injector voltage and current, which we have right here. We can see the pulse width period. I always want to call it dwell. I'm just so used to ignition stuff. The pulse width period here, that's the on time of the injector. Nice inductive kick. Can't see what we're hitting here on our kick, but amperage looks good. We can see a pental hump here. On the rising slope of that amperage waveform, we can see the pental hump here after the injector is closing. After our inductive kick, there's that little bump. That's when the injector closed. So from there to there is our actual time that injector's flowing fuel. And then is this our fuel pump? Fuel pump at fuse F66. It's a 20 amp fuse. And if only Ford would label the fuse box for us, it would make our life so much easier. Pulling around 6 amps. Let me go to the next screen here. This is just zoomed out. Let me go back one. So he was talking about the little bit of noise and interference. Some vehicles like capture really clean signals, and some have a lot of noise. I'm not sure what it is. If the vehicle just has a noisy electrical system, most of them it doesn't cause an issue. But a little bit noisy. We see a few anomalies here, but it's hard to tell. That one kind of lines up with our. We can see a spike here that might be from the ignition system. But all in all, fairly even. Thank you, Angel. And then this one's a Mercedes. Is this Mercedes? Mercedes-Benz 920. I probably didn't read far enough. Fuel pump waveform, bit choppy. Oh, this one says MB920 fuel pump known good. No, it says the same fuse here. And the notes down here, so I'm not sure if that is referencing something else or not. But the fuel pump slows down at this point right here. I'm not sure if this Ford on the 6.2 has a fuel rail pressure sensor and has a variable fuel pump. I believe Doug posted up a capture for a variable fuel pump on a Ford, but it looks like we're sitting around 10 amps initially, and then it drops down to that 5 amp area. So it might have been running higher fuel pressure on startup. Paul Smith has a 2013 Silverado with no fuel pump issue other than the typical P0463 fuel level circuit high voltage. So the fuel sending unit has a bad spot, but no problem with the fuel pump. And he's probably checking the fuel pump just to see how the waveform looks, because if you're in there that far changing the sending unit and you have a junky looking waveform on the fuel pump, you may as well replace the fuel pump at the same time. So zoomed out with the ATS scope, this is the total capture here. And then he has a zoom in here. Now, we do see some anomalies in the waveform. They do drop down, but you know, we're within half an amp. I would say that's a little bit suspect, and I would probably consider doing a fuel pump while I was in there. But if there's no complaints and everything's working fine and the pressure's good, then we may let it slide. Oh, it was actually in for a transmission problem. I pulled a vehicle in the shop this afternoon. It came in for a transmission whining noise after another shop worked on the transmission. It's supposed to snow tonight or tomorrow, so I figured I'd pull as many vehicles in as I can. And I pulled it in, and the power steering's whining. It's one of those ever since, yeah. But, so it wasn't even in for a drivability complaint or for the fuel level circuit. But thanks for grabbing that one, Paul. Chevys are normally pretty easy to grab. They have a fuel pump relay in the underhood fuse block. You can put one of those jumpered relay deals where you just flip the switch and it has the little loop for your amp clamp. I believe Innovative Products of America makes most of them. Some of them you might be able to get Lyle. I can't remember. But most of the tool trucks sell them as well. They just rebrand them. Michael Mack has the fuel pump current threesome. He was testing a vehicle while he had this stuff hooked up. He decided to go ahead and test it with the Pico, the Autel, and the U-scope. So here's all three of his screens at once. And that's the thing. Once you have the connections made, if you guys have multiple scopes and you're learning different scopes, once those fuse loops are in place or your back probes are in place, sometimes it's a good idea to get multiple captures. If you're using test leads, like I have the AES Wave test drive leads hooked up to my scope on my Snap-on, and I could piggyback connectors into the back of them. They're a dual banana jack. So I can hook the Pico scope straight up to the back of the Zeus and capture both at the same time if I want. And I don't even have to touch the connections at the vehicle. So we have the U-scope, and we're at negative 100 millivolts to 700 millivolts. So I'd say, what's that? 0, 1, 2, 3, 4, between 4 and 5 amps probably, depending on which amp clamp he's using. The waveform looks pretty even. The Autel, which I still haven't got my hands dirty on the Autel. My brother has one. I just have a hard time picking it up. But the waveform looks a little bit different, but at least with the Autel we can zoom in and out a little bit. And then we have the Pico scope, which I'm a little more familiar with, and we're between 4 and 5 amps. The waveform does look pretty even, but at least it has a little bit of repetition to where we could throw some cursors up and measure our fuel pump speed. And is that the same one? Yeah, he's connected at the circuit opening relay. Is that what it is? I'll have to read your notes again. Adding a jumper to the circuit opening relay. So the circuit opening relay on a Toyota is the fuel pump relay, and it normally powers just the fuel pump. Now the fuse that feeds this, that comes off this red wire, is probably like an EFI fuse or something, and it may go to multiple different components. And is Michael in here today? If you are, let me know if that circuit opening relay is in the underhood fuse block, or if it's typical Toyota fashion and they bury it under the dash somewhere. I don't know if I have seen one of these vehicles. A Toyota CHR. It must be a newer model or something. I'm not sure. We have the RAV4 and we have the Highlander. I don't think I've seen a CHR. Hans Jorgensen, 2003, of course, Volkswagen Eurovan, came in as a no start. Michael says it's under the hood in the fuse block. Now, is this an actual Toyota, or is this made by somebody else? I know Toyota's been doing a lot of shopping from other companies and rebadging stuff. Just like the Yaris IA, the Mazda, I think. The Subaru BRZ or Toyota FRS, the BMW Supra. Toyota used to sell out to other companies, like the Geo Prism was a Toyota Corolla. So Hans has a 2003 Eurovan. He's been away for a while, which is okay because I've been away for a while. But at least he got to go to Germany. We just stayed around the house and did some housework. We're not done. My house is a mess because I'm remodeling a bedroom. Details in the notes. So this one here had a kind of an interesting story. This fuse has the injectors on it as well. So he normally doesn't use that fuse, but he didn't want to crawl all over the place because the van got broken into and there's glass all over the place. Otherwise, he could have got to the fuel pump supply wire. Luckily, the pump was bad, so it didn't matter. The negative space in the waveform is the injector current. So we can see that sometimes this waveform offsets a little bit around the 1 amp mark, and then sometimes it drops down and then it's back up. Well, that's the injector firing. That's the injector ramp. But still, if we're looking at the fuel pump, like there's a section here where the fuel pump's not running at all, and then it's running, but it's kind of choppy, and then it quits running again for a second, and then it starts running again and quits running again. So even though there's noise on that signal wire, we have other stuff on there, we can verify that this fuel pump has an issue. Okay, so the CHR is a Mazda badge as the Toyota as well. I'm not sure why they're doing that. I mean, does Toyota really need more models? Or can they just like limit, sorry, I bumped the mic, limit down to what they can manufacture themselves? David has one, it's fuel pump current, gasoline and diesel. So he has a Honda CR-V 2.4 from a 2011. And this pump is running at 8,100 RPM. That's pretty fast. I just want to double check because it has frequency on the left side. So 135 times 60 equals 8,100 RPM. I think I have captures from a CR-V that I was pumping the diesel fuel out of. So it was a gasoline that they had put diesel fuel in. I'll see if I can pull that up here at the end, and we'll see what my pump speed was. I can't remember. And then he has a Hyundai Tucson with a 2.0 common rail diesel. It's common rail direct injection diesel, 2005. And this pump was only running at 3,200 RPM. Now, diesel fuel is probably a little thicker. The pump probably doesn't have to pump quite as high a pressure, depending on the system. This could be just a lift pump, but it is pulling 8.5 amps, but is running at a slower speed. Thank you, David. Oh, and there was a discussion about this waveform. This pump, the waveform is kind of choppy. We see some kind of glitches in here, and several people said that this pump does not look very healthy. But I believe that David said there wasn't any drivability concerns. And no, that one is not. Ruben posted one. I believe this was a pulse sensor in the radiator and relative compression check. We will be getting to that shortly. And here's his fuel pump current. Here we go. So even this one looks kind of choppy. It's not a real consistent, even waveform. It just has a little bit of noise to it. But there's no major dropouts. I'm not sure what the amperage is. It's off the side of the screen. But if I had some big dropouts, then I'd be a little more concerned about it. Same with that CR-V pump. But nothing really extends past the minimum maximum amplitude of this waveform. So we don't have a repeated pattern that would say, hey, I have a bad commutator bar. Maybe we have a slightly different waveform because that pump speed is fluctuating a little bit from impeller wear, but it's hard to tell that as well. Richard Cook, 2013. Not a 2013, a 2004 Acura TSX, week 13. Fuse loop is in place of the PGM FI Relay 2. And I didn't know they had two of those relays. Did they finally separate that relay into two relays? That's why we don't see issues with them anymore. I'm used to the late 90s Hondas that the PGM FI relay would fail all the time and leave you walking. This one here is a 44 to 55 PSI returnless fuel system. And he has a waveform here. We are looking at pretty well even pulses here. And our measurements... Oh, I haven't used Pico 7 much, but it has the pump RPM here. So we were at 156 Hertz, and that pump is running at 9,300 RPM. That seems really, really high. Just making sure we're lined up on the same one. So 1, 2, 3, 4, 5, 6, 7. We're not lined up on the same one on this one, Richard. It looks like this cursor should have been placed right here, and that would probably drop that pump speed down a little bit. So just one spot over. But our amperage looks pretty well in the range we've been seeing, 6 to 7 amps. And I would say that was probably going to drop down to less than 8,000 RPM once this cursor gets moved over. And then here's the PGM FI relay number 2 that he jumpered to power up the fuel pump. Was a different one. John Webb. 2003 Tacoma V6, known good. Fused loop in place of a 20 amp EFI relay. And he said the Hertz times 60 gave him roughly 6,400 RPM. The pattern repeats every 8 sectors. And he was zoomed in a little more at one point. Realized cursor number 2 is in the wrong spot, but you get the idea. It changes my frequency as well. So his frequency may be slightly off, just like we saw in that last one. So this one here, yeah, we are zoomed out a little further than what makes it easy to measure. But it's still a distinguishable pattern here. So you can get that measurement. And he has at 106 Hertz here. But if he moves his cursor to the right spot, let me just count here. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we're like 2 spots over. So that pump speed is probably going to drop down a couple thousand RPM, which is probably still good. And it's a Toyota Tacoma, so it'll last until 400,000 miles or better. And he was jumpering he had a fuse jumper in the EFI fuse location. Now this is one that I mentioned that we may have multiple devices running on this one, but luckily he had a nice clean waveform and he even had the engine running. So this one, he said it's a manual transmission in the comments, and he said that some of the wiring went to automatic transmission related stuff that his truck doesn't have. Let's see. Ruben has another one, 2005 Dodge Dakota 4.7. And this one he actually put the rulers on. So it says 720 degrees here. These are the engine rotation markers that are normally on the right side of the screen. He dragged those over and then he added rulers, which just lines up all the pumps, or all the humps. And so it's not 720 degrees of that pump. It's going to be 360 degrees, but at least all of those line up properly. I believe doing it this way, if you had the measurement tab open, or if that was showing you the RPM, that RPM will be incorrect. It'll be, I think, half the value of what you need. But I didn't even think about putting the rulers up to make sure that, you know, the pump's not slowing down and speeding up at different times. And this, I believe, was not the same vehicle. That other one was a Dodge. Ruben posted this one. 2006 Toyota Sequoia 4.7. So there's a weird hiccup here as it turns on. I don't know if that's the relay contacts just taking a second to engage. And then we get our pattern here. There's a slight hiccup, but it's probably nothing to be too concerned about. And if we zoomed in on that, it would amplify it quite a bit. but on pump turn on, it pulled about 12 amps. That's not a test I normally do, and it's something that I'm not familiar enough with to see what the inrush current to the fuel pump, if that's excessive or not. And then Scott's posting up, looks like ignition. We have a Ford Transit. So this is from a few weeks ago. I mean, it's not posted from a few weeks ago, but this assignment was from a few weeks ago. And we have a multi-strike ignition. This one, he had water running off the windshield into the coil, but it wasn't misfiring when it came in the shop. It had misfire codes in history, but everything was working fine. I believe they just cleaned out the water, fixed whatever was leaking on the windshield. I think they probably just cleaned it out. But improperly installed aftermarket windshield, allowing water from snow melt to drip between the windshield and the cowl right under the number 5 coil. And 3.7 is going to be similar to the EcoBoost, so it's not the Ford modular system. So at least these coils are mounted in the center of the valve covers, where they're normally a little better protected, but this one obviously had some water running onto it. Doug Wilson, 2011, F-150 intermittent no start. The only code was for a no-com fuel pump control module. So these fuel pump control modules, there's a, I forget the terminology. There's 2 lines. Fuel command and fuel monitor, I believe. It's been a while since I've had one in the shop to actually look at it. Give me 1 second here. Okay, the whole time he was testing, he could not find a glitch. Once it finally did, the scope was not connected. That's how it always is, like Murphy's Law. As soon as you unhook that scope, or as soon as you walk away from something, is when the vehicle acts up. He ran the Ford Keon engine off test, and it stored a code for the fuel pump module circuit open. No communication fuel pump module to all 8 injectors. Open circuit, check the diagram for a common denominator. Found power to the module, and the injectors came off the same relay. Replaced the relay, and problem did not return. Luckily, decided to do the Keon engine off test. Went to scope it again, and lo and behold, fired right up. So they just replaced the relay. But he was able to get his captures here. This one should be the pump amperage, which is going to look a little bit different depending on what that fuel pump control module is doing. So it may vary slightly if it's commanding lower than maximum fuel pressure. So here's zoomed out. And I think the red trace here is that control circuit going to that pump, I believe. So we have current and control, unless this was a control going to voltage going to the pump. So we see a square wave here. Our pump oscillations pretty much line up with the square wave signal we're seeing. And Doug Wilson has lots of channels hooked up on this one. It looks like we have... Doug, do you have 8 channels hooked up to this one? No, 1, 2, 3, just 4, 5. 5 channels hooked up. And zoomed all the way out, it looks like just a bunch of noise. Luckily, with the ATS scope, you can zoom in and you can turn channels off and kind of identify stuff going on. Doug says he thinks he had 7 channels hooked up on this one. I mean, all 8 channels are lit up green on the right, but I don't know if that means that they're all hooked up. I haven't got my hands on one of those scopes, but I'm sure that I would find myself in situations where I have all 8 channels hooked up. And especially when you have an intermittent problem, those extra channels are super handy because you don't know what's causing the stall. So if you can hook up to the fuel pump system, fuel pump control, voltage, ignition, injectors, all of it at once, then you have a better chance of catching what's happening. Thanks for that one, Doug. I think that was it. I do want to go over this one. Paul had a pretty cool post in our off week, which ended up being 2 weeks. It was supposed to be 1 week, but I just got so far behind with everything that it turned into 2. He used his WPS pressure transducer to measure power steering pressure. I've never tested power steering pressure ever. I don't have a test kit for it, and it could be that I'm also too lazy. Like, I know if I buy the kit, I won't use it as much as I should because they're always difficult to get to the lines. But being that this one had a Hydro Boost, maybe Paul hooked up at the Hydro Boost. Complaint was hard steering effort and the brake pedal was pulsating at an idle when the truck was not moving. Hooked up a mechanical gauge and the needle was all over the place. Wanted to see what was happening, so he hooked up the WPS and took a capture. So this one here we can see, oh, snap-on transducer. Okay, he's using the snap-on transducer. I just assumed you were using the WPS. And is this the 500? Yeah, 500 PSI transducer, I'm assuming. But this waveform right here, yeah, we're on the 500, and it shows that he had it calibrated. We see huge dropouts, almost to 0 pounds of pressure in this power steering pressure line waveform. So I recommended a pump, and he wanted to find out what was going on. I love this. Sometimes it's not good enough to just change the part and it's working now and send that core in. Let's find out what actually happened. What is causing this waveform to do this? And is it something that could have been prevented? Is it something that I'm going to see more often? Or is it something that now, whenever a vehicle like this comes in again and I feel that, I'm going to know exactly what it is. And this section of the pump was actually cracked and broken. Now, it almost looks, it could be the picture, but it almost looks like that portion, like that angled section is a smaller angle for those vanes than the other portions, but it could just be an optical illusion from the picture. I've only taken apart a couple power steering pumps, but normally it's just, to like replace a seal or something. If it's one of my own vehicles, then I can get a seal kit. Because old Toyotas, the pumps normally don't fail, but they leak. So if you can reseal it, then great. If not, you can. I normally put a used one on because the new reman ones are they're gonna leak too. So then, is this the after? Oh, that's the initial startup. And then he was creating a restriction until he reached the transducer limit. So I don't know if you pinched off the line. It went up and maxed out the transducer. Okay, so his pressure tester can create a restriction. Twisted the knob, and I believe it was a Matco kit. Let me go back to your other post. I think you told me which one it was and with the part number. In case anyone else is wondering, it was in the main feed, I believe. It was a Mac Tools PST22AB. I don't have a Mac tool dealer, but I will be looking for one of these kits because I don't have one, and I want to have one now ever since you posted this up. And I have the snap-on pressure transducers as well. I really need to go through all of my fittings and attachments that I have for my WPS and my regular fuel gauges, and I need to make some adapters for the snap-on so that I can use them all seamlessly together. I don't grab them because I don't have quick disconnects threaded onto them. And everything I have has the Foster quick disconnects. And then Doug has several posts here on ignition. So Doug got some of the new ATS ECOP probes for coil on plugs. I remember seeing a post from Doug on Facebook that has they have a different color, so you can match all the channels of your ATS scope. And I think a couple of the colors were unavailable. Did you ever find those other colors, Doug? But he was just becoming familiar with them because they operate slightly different, give a little bit different waveform than he was used to. So he's becoming familiar with them to make sure that he doesn't misdiagnose a vehicle that comes in. So seems like a great thing to do whenever you get a new piece of equipment, is to test it on known good vehicles and see what happens. So we see our dwell time here. Coil turns on. We see some oscillations in that coil pack. Inductive kick when it fires a spark plug, and our burn line, and then ringing for the leftover voltage over here. And then supply returning to charging voltage. Let's see here. I get so used to the picoscope, how it has the multiple channel voltages listed here on the side. But we see some slight drop in voltage here as that gets turned on, and then it jumps up and returns to charging voltage. He zoomed way out because of the inductive kick that happens on that primary side. And Doug has several other posts based off of those probes as well. Here's another one. 2006 Toyota Tundra, 4.7 liter smart coil. I always have a hard time getting good captures on the Toyota smart coils, but this one looks like it's doing a pretty good job. And then that one was a different type of case study, stuff we haven't covered yet, but he had a burnt valve. And I haven't seen all of these. I kind of took a step back from social media a little bit. The last couple of weeks we've been so busy. I was scheduled for vacation last week, and I went to work anyways, just because we have too much work scheduled and not scheduled sitting there to get done. So I went to work and worked most of the week. And I think that might be it for the new posts. Yeah, now we're back into week 11 and 12. I will refresh and make sure that there's no last minute waveforms posted up. See if Daryl posted anything in here. Nope, the last one is Bob. Daryl always sneaks one in there at the last minute for me. Normally slacking this week. So I think that's it. Did you guys have any questions or comments on the fuel pump test? I don't know if I explained it good enough in the video. If there was anything I missed, let me know, and I'll try to do a follow-up video on that if I can. My schedule is still crazy busy. I did get some time today to go do some ASE testing, and then I started filming a video for tomorrow. I haven't started editing yet, so it's going to be probably tomorrow evening before that video gets released. I've got one more ASE test to go. Today I wasn't sure if I should or not, but after taking the hybrid class that Isaac Rodell did with WorldPack during the PAVE training event, I decided, what the heck, let's take the ASE L3 hybrid test. So I took that, and I did better than I expected. I didn't fail it. I think I got like an 88%. So I feel like that was a respectable number, considering that most of my service on hybrids is just maintenance. We've done a couple of battery packs, but I don't have to do real heavy diagnostics on most hybrids. We have a very low humidity in our area. It's either they come in with a battery that has a completely dead cell and there's nothing you can do for it, or they just run forever. And then what else did I take? I took the parts consultant. I took the X1, which is the exhaust test. And if you have like A5 and 6 and you take the X, then you get the undercar specialist certificate. I took the parts consultant test. Last time I took the service consultant test. The only one I have left, and I'm putting it off on purpose, is the L2, because when I signed up for it, I thought that it was just going to be like a more advanced diesel one. Like the A9 is for light duty diesel. I thought that the L2 was a little more advanced than that, but it has a lot of medium duty and heavy duty truck stuff, and I don't work on those. So I'm a little interested to see how well I do on those. I'm assuming the systems are mostly the same as the light duty, but even the particulate systems, we don't see that many issues with them. So I'm not 100% familiar on all the testing methods for those, at least not, just going out and doing it. I normally have to reference service information for those tests. Paul, I don't know if he mentioned the U-scope at all for the hybrid testing. Most of what he showed in the training course was the mega ohm meter, and then using a good like category 4 voltmeter, and then there wasn't much of any lab scope testing actually, because I was kind of hoping to pick up a few things for lab scope testing, but I know that you have to use special amp clamps that go like around each of the high voltage cables or something, stuff that I don't have. So I don't think he covered much of that. The training is still available. If you guys want access to a bunch of training, I think it was $300. Pavetraining.com, I believe. I will look it up right now. You can access most of the information for another 3 or 4 weeks. I will put a link in the chat here, just in case you guys want to see what it is. All of the recordings are available for at least the next couple of weeks. It was 6 weeks after the event you had access to it, and the training was on January 8th is when it started. Oh, trying to be funny? Yeah, I didn't know if he used an iScope or U-scope in some of his videos or not, or in some of his classes. But let me find what screen I'm on here. No, we have not used our U-scope on a hybrid yet either. I see what you're referring to now. You were talking about our U-scope go boom test. But no, it's a really good test, and I asked in the class, it's like, what other classes should I attend to prepare for the L3? And I think Isaac said there was a couple other classes that are worth looking into. I decided, what the heck, I'm registering for a couple other classes. I took the G1, I had to recertify that one as well. I signed up for a couple other classes. I may as well sign up for it, give it a shot. If I fail, I know I need to study more. If I pass it, I know I need to study more, but at least I have a basic understanding of how the system works. So I know that the world is going to move into more hybrids and electric vehicles, so I want to get some sort of training for those systems, like a hands-on training. Most of the hands-on training events for hybrids are expensive. I typically see them anywhere from $3,000 to $5,000 for a week-long training event. So it's really hard for me to justify. Daryl's here. We were looking for your post, Daryl, and we've been waiting this whole time for you to post in the group, but I haven't seen your post, so we'll have to start over. But yeah, the just watching that one webinar from Isaac, I bet you 50% of the questions on the test was stuff that he covered in his webinar. And the other stuff I could just kind of basic electrical. A lot of it was basic electrical, and then some of it was just based off of personal experience with some vehicles as well. Okay, no worries, Daryl. Daryl, in case you missed it, the video for tomorrow probably won't come out until later in the day because I haven't started editing yet. 2-speed Toyota fuel pumps. Now, didn't Jeep used to use a 2-speed pump? I vaguely remember they just had like a ballast resistor and a relay, so they would switch the pump load that way. I believe my an ex-family member had a Jeep that had a pump like that. I'm not sure if Toyota does it the same way or not. So, interested to see those captures, Daryl. I think that's about it. I will mention one more time, pulse sensors. I have several to give away. Some of them are not ready to give away yet. I have, I think, 2 that are ready. If you guys need a pulse sensor, I'd much rather give them to somebody that's going to use it and use it in the group than doing a video and having a giveaway, because if I title anything with a giveaway, we're going to get a bunch of random people that normally aren't in here, and I don't really necessarily want one of them to win. I want one of you guys to get it. So if you need a pulse sensor, let me know and I will try to hook you up with one. Whether you reach out to me on here or on Facebook, Chad Austin on Facebook, or Instagram under the Practical Mechanic if you want to send me a message, or Twitter, or you can send me an email. However you want to do it, let me know and I will see if I can get one sent out to you. There is my email address if you want to send me an email. And then one of them is sponsored by Keith DeFazio. He paid for it. I have it here. No one's reached out to me yet needing a pulse sensor. So if if you guys need one, let me know and I'll try to get one sent out to you. I don't think I can send one across the pond easily. Canada, I can probably do. So North America, no problem. If you're across the pond somewhere, then I'll see if I can help you out. But I don't know. Oh yeah, Paul's reminding me of stuff that I forgot to mention, or I mentioned but I forgot to post up. The Delphi pump application guide, I think. Let me make sure this is what I needed. And this has lots of good information. Okay, let me switch screens here. So this is, I'll post this link up as well. You guys are going to want that. I don't know if that link is going to work. It's a weird link, but that's the website I'm on. It's a link from Delphi. Only found the part lookup. Okay, let me verify that this is what it is before I say yeah, this is what you need. I'm just gonna pick a random vehicle here. MDX. Let's go to fuel pump. Where is fuel pump? Fuel pump assembly. Is that it? Do they have a chart here? Let me check one more thing. Program information sheet. I was just on it the other day as well. I'm going to turn off the search here just in case we end up somewhere where we're not supposed to be. I don't need YouTube coming down on me. Let me see. I can't remember where I found the link, if it was on a diagnostic network. It might have been that might have been where I found the link. But it had an application guide just like that. But once you punched in the application guide, it would give you the spec for the fuel pump. Unless it's in my history. I hope I can find it because it was a very good chart of all the fuel pumps. Yeah, Dave Hobbs is the one that mentioned it. Now, I don't remember if that's where he linked it or if that's... I was sure that it was on IATN. Or not IATN, on Diagnostic Network. It could have been on IATN as well. Just scrolling through some of his posts on Diagnostic Network. I don't have direct permission to use their content on here, so I will I will refrain. I know I sent out emails to IATN back in the day and they said no go, can't use our information. I may have to find it again because it had that same application guide, but it showed the specs and what the amperage was, and I used it when I was looking up the amperage on a Chrysler the other day. Fuel pumps and modules. Oh, it's all right, Paul. I completely forgot, and I said I was going to do it. So I'm just scrolling through. I'll give up here in a few minutes, but I'll look for another second here just to make sure that I'm not missing it on their website. Yeah, I'm just not. Okay, this one has it. Let me I just switched to a different part number, so I am on that same page that I linked before, but under the part number I looked up a Ford Edge, and there's part information. And this one says that it was 51 psi as the system pressure. And where was the amperage? I saw it on here. Product attributes: average current draw 10 amps. Gasoline fuel type is gas. It gives resistance of the sending unit. So it was on this site. I just apparently that Acura didn't have it. Maybe it's because I went too old. Let me try another vehicle here. Fuel pump control module. They show one option here. Part info. So, okay, so that website will work. This one here pulls 7 amps, 45 gallons per hour, maximum pressure 94 psi, sending unit resistance. And I don't know if they only show the specs for stuff they do for like OEMs, or if they actually show it for their aftermarket replacements. I'm gonna try a Honda. Yeah, it's all here. Okay, it keeps trying to send me back to images. If I click on part info, then it has all the information we need. So that is the website. Did anyone try that link and see if that link works? To get you to this same screen, the application guide here. I mean, it's kind of like an old school catalog, but it's fairly user friendly. Try another one here just to see how much information. Okay, so you do have to, after you switch vehicles, you do have to click on part info. It looks like they have most vehicles in here anyways. 6 amps, 32 gallons per hour on this 98 Jeep that I clicked on. So that's a useful one. For some reason, that first Acura I clicked on, I don't know if I clicked on part info after I picked the vehicle, because the image wasn't really that helpful for me. But at least they do have the information on their website. It's very, very useful to have that. I should probably save this in my favorites right now so that I can come back to it. And all I did was type in Delphi fuel pump spec list. And then on their website, if you end up in here, it was in the catalog. And the website address is kind of a strange one, but I will save it to my browser anyways. Hopefully it comes back up. So if you're doing your fuel pump current draw testing and you say, hey, this vehicle looks like it's pulling a lot. I had a Chrysler in the shop. I think it was a Dodge Avenger, and it was pulling 13 amps. I'm like, well, that pump's no good. And I looked up the spec, and it was exactly what Delphi said it should be. Okay, I think that's it. We're going to wrap it up for tonight. Sometime tomorrow, I'll try and get that video out. It may be Monday, but I should be able to get it tomorrow, as long as I recorded everything properly and all the shots are not blurry and I saved everything properly. Otherwise, I'll just go back to the shop tomorrow and refilm. And we'll see you guys live again. Should be next week. My schedule's kind of iffy at the moment. So if for some reason I'm not going to be live, then I'll put up a post on YouTube, on the community forum, and in the Facebook group letting you guys know that I won't be live. If for some reason I don't go live, then I didn't have time to post it. And sorry about that. So I'm giving you a warning now. If you need a pull sensor, or if you know somebody that needs a pull sensor, let me know. Doug Wilson, I don't know if you were mentioning Ronnie Loy because he needs a pull sensor or not. But if you know somebody that needs one, or if you need one, contact me and I'll get you hooked up. Okay? Is he on Facebook, Doug? If he is, I'll reach out to him. If not, then just send me a message on Facebook, and we'll try and get in contact with him and get him a pulse sensor. He's in the group. Okay. The first pulse sensor I'm gonna send out is one from Cody's Auto Diagnostic. It's one that Keith DeFazio paid for to give away in the group, and we haven't got to that point yet. That was about a month ago. So that'll be the first one that gets sent out. So I will contact Ronnie and get that taken care of. The next ones are going to be Nicholson pulse sensors. Kate Jira said that Jake Seth in the group needs one as well. James, are you in the Facebook group, or are you on friends with me on Facebook or in the Facebook group? If you are either one of those, then you can send me a message that way. And then if not, send me an email. So far that's 3 down. I think I have one more to give away. And if it doesn't happen today, that's fine. We will start using those in waveforms. Actually, tomorrow's video is going to have one included. Or I'll be getting a capture with a pulse sensor. So that'll work. And either way you contact me, James, whether it's on Facebook or via email, I'll try to get you hooked up. Okay, thanks everyone, and I will see you next week.